Let's see if I can install a Watermaker in just a couple of days. This would actually be very possible if I wasn't always complicating things a little further. Of course, the first step was to choose a Watermaker. There is different type of Watermakers, and I'm going to get into the differences in just a second. In our case, we also had to decide between an old Watermaker or shelling out the money for a brand new one. Some of you that have been following for a while might also remember that friends of the channel had offered a Watermaker to us, and we picked it up. We were very appreciative of that. But as I was doing research, I basically came across a few challenges. The unit that we received uses a high pressure pump, and high pressure pumps mean higher electrical demand. That would be totally acceptable, but unfortunately the company that made that Watermaker had been bought by a different company at this time. They no longer made this model. I tried to think ahead and think of what spare parts I might need once I get it all installed. I started looking into it, and that's when I learned that it's going to be very hard to find spare parts for it. So that's when we started the research again. Starting fresh, maybe adopting a different design of Watermaker. Broadly speaking, there is two kinds. There's those that apply big electrical draw using a high pressure pump, because you need a lot of pressure to squeeze water through the membranes to extract the fresh water and leave behind the salt. But then I also came across a different camp of Watermakers, and those use a Clark pump. And that's a pressure intensifying device that we'll try to explain in a minute. But basically then you can get away with low pressure pumps which require less electricity to run. So now, knowing that there is these two types of Watermakers, I was pretty intrigued by the version that would require less electrical draw. Over time, like with everything, there is some lessons that can be drawn. There's always a version 2.0. So when I started to research Watermakers, I wanted to find one that would take into account those lessons drawn from the many years of Watermakers already being in use. And the other thing of importance, of course, is always price and availability. This was at the beginning of the tariffs when we were doing this research, and finding a Canadian company was really big on our list. And so this is when we came across Electromax, a Canadian company, and their advertising literally says that they have taken into account all of the lessons learned from Watermakers having been in use for many years now. And they have made those changes. They have swapped out for better materials. It sounded perfect to us. What I have around me is the SolarMax 340 level 1 made by Electromax. This cylinder, that is the actual Clark pump, which is what intensifies the pressure in the system. Over here we do have two feed pumps, so these create the initial pressure, but they only create 60 psi each, which is almost like any pressure water pump you may have in your boat for the faucet, for a deck wash pump. So the system, of course, always requires some filters, pre-filters, another little pre-filter from the raw water, electrical controls, accumulator tank to equalize pressures. And these two here are the membrane housings. So that is actually what holds these membranes in there. That's what one of these membranes looks like. They are wrapped in fiberglass to withstand the high pressures. Well, this is also fiberglass to withstand the high pressure. This one intensifies the pressure. Water runs through here under high pressure, which is what tries to separate the salt from the water to give you fresh water. Okay, here we have it, our little mock-up. Now you can see Clark pump underneath and our little mock-up on top. Now there is the long cylinder down here is represented, of course, by this one. The top chamber here is this little top chamber, and that one also has a little piston in it. And now we'll reverse roles, and I let the engineer explain this.
The bottom cylinder is a double-acting piston pump feed water coming in from this side, and on this side through the end cap, the high pressure water goes out into the membranes. So as it's pushing, the feed water is pushing the pump, the high pressure is coming out here, and then the ingenious design of the Clark pump is this little extra spool valve. This is a spool valve, this little thing here. The high pressure brine comes in through here, goes between the two cylinders, goes out through this port and comes to the back side of this piston and gives it all that boost to make it move. So do that again. We're starting the system by seawater from the feed pump coming in through this side, and the high pressure brine discharge coming in through this side to the back of this piston, and that brine discharge is helping to push, as well as the feed pumps are pushing it. So you've got that extra pressure happening. When you get to this point, the stroke has finished. Pressure differentials between the two sides and between the two sides of this upper reversing valve, it automatically, without any electro or any other spring or anything, it automatically shifts over like that. Now, what that means is the pressure water from the brine goes through onto this side of the piston. Feed water now switches to coming in through this side, and as it's stroking along, you have the brine discharge pushing the piston along, the feed water pushing the piston along, and the high pressure water now coming out of this side. It joins together, and there's check valves involved on the system that there's no backflows happening. It joins together to go to the membrane. And as this piston is pushing this way, what used to be the brine discharge port pushing it in the opposite direction now becomes the outlet on the yellow piece of yellow port here. So as it's stroking this way, brine discharge is pushing it, feed water is pushing it, and the water on this side goes out to the brine discharge and overboard. And then that just keeps on repeating. When it gets here, this switches over. Now it's pushing.
Now this brine is discharged.
Now this brine is discharged.
Here it's adding pressure, and here it's pressing from the feed pump.
And the pressure water comes out to the membranes. So there's no electromechanical solenoid involvement to make this happen. It all shifts naturally. Mm-hmm. This spool valve shifts by differential pressure, and that makes the rod go back and forth. The check valves feeding the feed water to it, and then the high pressure water going out through another check valve. It's all working mechanically with pressure differential from the different fluids.
Yay, Clark pumps.
Clark pumps, yeah.
Pretty much how they are sitting here is how they come pre-assembled and plumbed up, because the Clark pump, of course, is connected to the membranes with high pressure hose, and this makes a very nice compact unit. And then over here we've got feed pumps and a pre-filter and the electronic control module. And as you can see, this one as well is packaged up in a square, very compact format. All the plumbing is in place with very tidy 90-degree fittings, and you would basically just have to wire it up and plumb the input outlets and inlets. Pretty straightforward, pretty easy. You could be done very quickly. Now, where the complication comes into play is that we are a small boat and we had not planned for this addition previously. So I have decided to dedicate our port side for this installation. The components in this system are completely modular, which means they can be taken apart and I can place them in a different configuration as long as things are plumbed up in the same manner, of course. So unfortunately, I had to take apart this neat compact package, but because I think I have a scenario where instead of as a square package, I want to have them be longer but take up less depth. I worked on finding the perfect location for each component before plumbing it all up. Okay, on to the next mission, which is making my own high pressure hoses. I cannot use the specified length of high pressure hose they provide, but these are made using a hydraulic press. As with many things, I like to have it repairable in the field without a hydraulic pump. So Brian pointed me in the right direction. He told me to look for the SAE 100 mechanical fittings. So these here, they achieve the same function but mechanically. So you can see it's the same fitting at the end, but then this terminal gets screwed into that one, wedges the hose in real good. You do require a vise and a pretty long crescent wrench. I've assembled one side. I checked the length exactly as it has to go on the installation. Once it's made to length, that's pretty much the length you get. Hopefully I got it right. Probably would have been easier with an angle grinder and a chopping disc. So this thing is rated for 4,000 psi, which is way overkill. I only need it to be 1,200. Okay, in step one, the hose is inserted here, turning left instead of right. And then once this is on the hose, then this one is inserted here and it slips into the hose. Yeah, you'll see in a moment. Okay, first piece of the puzzle done, and you can see it goes more or less to this line here. So almost all the way, and I can just see the hose when I look inside of it. So next, getting this one down the throat of the hose until it butts up metal to metal. Ah, there we go. Yeah, when you use Vaseline, it actually starts off pretty easy, but towards the end, it still is a bit of a struggle to put them together. And hopefully it fits. Okay. There we have it. The hoses are installed, and the nice thing is these ends here swivel, so this end should go over there, this one over here. And on the next step I'll get a little bit wet because the membranes are filled with water. I'll have to remove the caps, get these one on, so yeah, I expect some water to spill, and soon I can bolt this Clark pump into place. Not gonna lie, this installation took quite a bit of time and work because of some changes I made. I guess one of the bigger challenges was finding parts. So these push to connect fittings. So literally There is an O-ring in there which seals it, and then there is this section which I guess is slightly tapered and has kind of barbs on it, so after you push in the hose you cannot pull it out unless you press this black ring back towards the fitting, and then the hose releases. A few things are missing though. One of them is I still need to install the through hole in the head that actually supplies the salt water. The hole is drilled, I'm just waiting for the valve. Then it's only a bit of plumbing through this strainer here, which is just to get seaweed and whatever particles. And then I also need to put in a through hole somewhere around here. I'll put it somewhere above the waterline or around waterline level, and that is for the brine discharge, so that when the system is actually running, you need to discard the salty water. Then I also, now that all the plumbing is in place, I need to get to the panel to actually operate all of this. Right now, actually, I'm going to take off the end caps from the membrane housings here and see if I can get the membranes out. That's the idea. I want everything to be serviceable. Oh, there we go. Would you look at that? Well, to my surprise, there's no membrane in here. I've been putting in so much effort to keep distilled water in it because I read the membranes should never dry out. I did receive membranes, but I had ordered spares, so my understanding was that the membranes that I received packaged were not the ones that should already be in the system. So I fetched the membrane, here it is, and indeed, even after checking just like this with the plastic packaging still on it, yeah, I can tell that the corner here unfortunately is in the way, so I'm gonna chop that off.
That looks so good, Aladino. What an installation. Are you happy?
Yes.
Are you ever happy? Not when it comes to your own work.
I just hope it doesn't leak. Towards the end of this project, I was definitely feeling less confident. There is so many connections involved, and I was pretty sure it's gonna leak somewhere. I also really couldn't test things before the boat would go in the water. So I just installed the new through holes and hoped for the best. So the timeline is a bit off here. We're gonna make a jump into the future, so to speak. I wanted to have the whole Watermaker install and first commissioning in one episode. So we launched the boat, went over to Gibson's, and that's when we did the test run. So Brian's aboard, let's make some water. Fingers crossed that there's no leaks. We'll just go through all the steps. So I believe the first one is kind of flushing the system before water reaches the Clark pump, and that's just in case there is debris within any of the hoses and the things that I've connected.
That's only on commissioning. That's not all the time.
And then it comes from the through hole. The valve is in the correct position. It should go through.
Pumps.
It should go through.
Through the filter.
Should we do one at a time?
Yeah. Okay, there we go.
That connection's not happy, hey?
That connection's not happy.
Okay. Should we pause them and see what we can do?
For sure, yeah.
Oh, yeah.
Was it in all the way?
It wasn't in all the way.
Okay, good.
Yeah, they're seeing good though.
With one pump?
Wow, no, that's both.
So far so good. So we just did the flushing, but we would still see if there is a considerable leak. We found one, and it was just because the tube was not connected fully into the fitting, so we pushed it in and ran it again. We bled the air filter, everything's running, we get good output of water. So now it's time to run it through the Clark pump. Pressure relief valve stays open and the whole thing gets bled and runs for 20 minutes before we increase pressure and we start making any product water.
Purging all the air out of it.
Yeah.
Bleeding.
Bleeding, purging air. So let's do that.
There we go. Yeah. Pump, pump, pump. What kind of pressure we got here? No leaks anywhere either?
Oh, it's still filling everything.
Yeah.
Oh. Oh.
Oh, stop. It's pissing.
Why didn't I tighten that one?
I don't know. That's what you forgot. Okay, try again.
Yeah.
Let's not put this away yet. We'll just roll it up.
Are you all first? Oh yeah, leak. That one's leaking.
Not either.
It's reaching 60. Feed pumps are about to implode.
Well, we can. Ooh, that was a shift. Of the Clark pump.
Oh, okay.
Now it's pumping out less. Now you hear it's pumping out less air.
Yeah.
And it's cycling quicker now. It says this shift should start to even out as air is purged.
Yeah, which it's doing. It seems to be a more even thing now.
So this may be hard to hear, but watch for the rise and fall of feed pressure as the Clark pump shifts, which is exactly what it's doing. Yeah. Yeah, so it's building, purging, building, and shift.
We have got it running, so now you can actually see it in action and listen to it. So yeah, it's been running for 20 minutes just to make sure everything is running fine. Both feed pumps are on. You can hear the piston in the Clark pump going back and forth. So I guess now we can make product water because now everything is being discharged through the brine discharge. But if we close the pressure relief valve, we should start making product water.
Let's go for it.
Let's do it. Half a turn, finger tight, there we go. And what does it do now? Ooh, okay. Pressure goes up.
Higher pressure.
Yep.
Feed pumps are working harder.
Oh yeah. Wow. Oh man, pressure is rising. 100 psi. And now it's about to explode. Oh yeah, there we go, product. Ah, look at it, look at it spit. Ooh, ugh, brown water.
Oh, that'll clear up quick.
Oh yeah. So now this went up. Of course, pressure is much higher now. Oh yeah, Brian is curious about power consumption, as we all are. Ah, now they're working hard. Oh yeah, now it's clear. Steady at 7 amps.
So basically 7 amps. Yeah.
Each.
It bounces 6.9 to 7.2 when it shifts.
Yeah. Well, and for
And
full
that would be each.
exactly full disclosure. So that's 14 amps. 14 amps. And right now we're making about 12 gallons per hour. So I guess it's time to take the test meter out and see what's coming out of here. Okay, here we go, filling a cup, and then turn the TDS meter on by pressing the on-off button. Immerse the TDS meter into the water solution up to the maximum immersion level.
14 ppm.
14?
14, which is fabulous.
So on first attempt, the Watermaker produced really clean water. So now we'll have to get into the rhythm of using one all the time and see how it holds up over time. But before we start the next sailing season, we have a few more boat projects to solve first. So the next episode, we're back in the boatyard working on some other projects. Thank you all for being here. Thanks for watching, commenting, liking, hyping, and all the other things that YouTube has come up with or will in the future. Huge thanks to our patrons, and an especially big thank you to the names now appearing on the screen. Now, if you would like to become a patron, you can do so for as little as $2 a month. You can support these creations, and that really means a lot to us. And also, if you haven't already, check out Maya's new book. She has written an incredible book that we have taken photos for over the last season, cruising the BC coast, and she has done an absolutely stunning job at putting them all into book format and adding stories to those pictures, to those photos. So yeah, check it out. It's the Northern Voyage second print run. Yeah, they were selling like they deserve. I am very, very proud of my wonderful wife Maya. Thanks again, and we'll see you next Friday.